Acha, so obviously after the yesterday's class, I went back and checked those questions. First thing, the 7.5 that we got, that's correct. Don't worry about it. And the second one, we have done a very silly mistake in the class. Very silly. Okay. So let's just correct that. So let's just take, I just want to make you recall which were the two questions. People, this question answer to this is 7.5 only. Don't worry about it. So whatever we got, that's correct. Okay. And second, this one. So the thing is, throughout our derivation, I have been writing acceleration A, but they have given the value of acceleration already, which is 5, and we have not substituted that. For example, it's just a 5 or 6 line problem. We just made a mess of it yesterday. Okay, so we have got weight mg in the downward direction. M is what, people? 1. So this is 1g. There is a normal reaction n1 in the upward direction. Okay, system is accelerating in the forward direction. It has got an acceleration of 5. But yes, what we are going to do is we will have our Sharad Khandi guy who is going to observe people, who is going to behave as an observer. Okay, and because you have placed the observer on the accelerated system, you will apply a pseudo force mass into acceleration in the backward direction. There is a tendency of acceleration in this direction. There is a tendency of acceleration in this direction. So let us say the acceleration with which it is going to accelerate in this direction, let's say it is A dash. We don't know the value of A dash at the moment. Okay, keep it as it is, no problem. Now, also, let's say this is our x-axis and let's say this is our y-axis. Okay, and after this, all we were supposed to do was resolve things. So normal reaction is not supposed to be resolved. We resolved 1g people in 2 components. You know, this is 37, this was 37. So this became 1g cos 37 and this became 1g sin 37. Okay, and 1a also we can resolve in 2 components. Again, this is 37, this becomes 90 minus 37, this again becomes 37. This becomes our 1a cos 37 and this becomes 1a sin 37. Okay, now the thing is, what is mass into acceleration? It's here, m into a dash. Okay, m is actually 1 kg people, so 1 into a dash. It is given by, which is the force in the direction of acceleration, 1g sin 37, which is the force in the opposite direction, 1a cos 37. Now people, the values are already with us actually. All the values are already with us. G is 10, sin 37, that's 3 by 5. Acceleration is given to us, that's 5. Acceleration is given to us, that's 5. Okay, and cos 37, that was 4 by 5. 5 gets cancelled. Okay, 5 ones are 5 twos are 3 twos are 6, 6 minus 4, that's 2 meter per second square. So it accelerates, the block accelerates with an acceleration of 2 meter per second square. This is the value of A dash. This is the value of A dash. Okay, so option A is wrong, option B is wrong. Because they have mentioned block will remain stationary, that's wrong. Block will remain, block will accelerate with acceleration of 5, that's also wrong. This is done. Okay, now after this, similarly, just write, is it oscillating up and down? It's not oscillating up and down, no? So total up will be equals to total down. So normal reaction N1, it is equals to what? 1a sin 37, 1g cos 37, that's it. 1a sin 37, 1g cos 37. The thing is, we thought that a is an unknown, but no, a is not an unknown. A is given to us 5. So this is 5 sin 37 plus g sin 37. Sorry, it's cos 37. It's cos 37 here. G cos 37. So we have got 5 sin 37. What is sin 37? That's 3 by 5 plus g into cos 37. G is 10 and cos 37, that is 4 by 5. Okay, so 5 gets cancelled. 5 ones are 5 twos are. We have got 3 plus 8. We got 11. I don't know what exactly did we do yesterday, but we made a mess out of it. It's a 4-line question. Okay, that's a normal reaction of the block is 11. And whatever will be the force on the block, that is the force that it is going to exert on the wedge. The normal reaction felt by the block, that is the force that the block will exert on the wedge people. Okay, so the force on the wedge due to the block, force on the wedge due to the block, that is actually same people. That is again same 11 Newton. But they have mentioned 2 Newton, so that's wrong. Answer is just option C. That's it. Okay? Take your time, go through this. Ask me if you have any questions. Don't hesitate. But did any of you try this after the class? Or you were like, or you did not notice that they have given us
Yes, sir.
acceleration was 5 years?
Yes, sir. I do.
You did it.
Try
Huh?
किया है.
Try किया था. Okay. हाँ.
हुआ
Good.
भी सर. आंसर सेम आ रहे थे.
आ गया ना बस. Good. Make a note. Wow. Just imagine, if this question was there in the job and we would have made a mess of it like yesterday, and then after the exam, we are realizing that it was such a silly question, but we forgot to just substitute the value of acceleration. That's very heartbreaking. No? Why am I telling you ghost stories? I should tell you motivated stories. Okay, we'll be able to do this. Chalo, done? Any questions, anyone? Those who joined late, if you have any questions in this resolution or whatever, like resolving forces in this diagram, you can ask. All good? Should we proceed with the next questions?
Yes, sir.
Chale? Chalo, next. Please ask me if you have any questions, okay? I'm going to the next page, let me know. So I think now there is no problem. I cleared the two confusions that we had yesterday. The 7.5 kg, that's correct. And this one, this is also correct, okay? Chalo. Now let's take a new question, people. This was question number 8. Now I want to take question number 9. Let's take question 9. Okay. Okay. So this is related to friction. Okay. So first let's recall friction. First, let's recall friction. So, there is nothing much to remember about it. Important, there are two things that when you talk about static friction, people, it is not always mu s into n. Okay, it is just less than or equals to mu s into n. It's a self-adjusting force. It's a self-adjusting force. That is important. The point is, if this is a block, if this remains at rest, if you will apply a force of 1 Newton, friction will also apply 1 Newton. It will remain at rest. 2 Newton, friction will apply 2 Newton. 5 Newton, friction will apply 5 Newton. So friction is a self-adjusting force, static friction. But once you cross the maximum friction, let's say 25 Newton or something like that, after that, friction will apply its maximum potential, that was 25, and now it cannot adjust. Now it is just going to apply its maximum possible friction. We did this very nicely during our regular lectures too. But the point is that it is always less than or equals to mu s into n, and the maximum value is mu s into n. So only if people, the applied force, only if the applied force is greater than Fs max, okay, the object will move. The object will move. Otherwise, it will never move. No, it has to be greater than the maximum friction. So if maximum friction is 25, you have to apply 25.1, 25.2, something greater than 25, so that the object moves. Okay. But if you apply 24, friction will be 24. If you apply 20, friction will be 20. It's a self-adjusting force. It is always less than or equals to mu s into n. Okay. And then kinetic friction, however, that is always mu k into n. So once the object starts sliding, suppose once you applied that 25 Newton and once it starts sliding, then friction changes its behavior. From static, it becomes kinetic. And what happens to kinetic? Is that friction greater or smaller, people, than static?
Smaller.
Smaller. Okay. Please remember that the kinetic friction is smaller than the static friction. Okay. So friction reduces. So it's like you kind of get a very sudden boost as soon as the object starts moving. Friction all of a sudden reduces. Fk, which is mu k into n, it is less than or equals to max. Sorry, it is always less than maximum static friction. The value of Fk is less than maximum static friction. Okay. Any questions? Anyone? Please ask. Chalo, next. But this was the only theory that was that we learned in friction in detail, and then we took problems. So let's just take one problem on that. This is just an interesting one, and hence, otherwise, so mostly we have taken good problems in the class already. But still, a fireman of mass 60 kg slides down a pole. He is pressing the pole with a force of 600 Newton. The coefficient of friction between the ends of the pole is 0.5. With what acceleration the fireman slide down? Now you need to imagine this situation. Tell me one thing. When the person is going to slide down the rope, if you will not press the rope, people, if you will not press the pole, what will happen? You will
Free
fall with
fall.
gravity, no? Free fall. If you will not press, okay, so you will fall with gravity. So that, and basically the person is, suppose here is the fireman, okay, let's say here is the fireman, and here he has his weight mass into gravity in the downward direction, okay. But now that he is applying a force, people, he's pressing the pole, because obviously when you will also try to slide down, you have to hold it, you'll have to press it, correct? Only then it sliding can happen. Otherwise, if you will not press it, people, what will happen? You will undergo free fall. It's very logical. So he is applying a force, people. He is applying a force here of how much? They have mentioned 600 Newton. He is applying a force of 600 Newton. So obviously there will be reaction also. It is just like if you are standing on a platform, there is weight. So there is normal reaction. So if there is push, then there is backward reaction, equal and opposite. So there will be a reaction also of 600 Newton. Okay. Now, in which direction will the friction act? Opposite direction of acceleration. So since the person is sliding down like this, friction has to act, people, in the opposite direction. Okay. And because they have mentioned it is already sliding, people, it means maximum friction has reached. Maximum friction has reached because it is already sliding. The person is already sliding, people. So what is the value of the maximum friction? Mu s into n. Okay. What is mu s? 0.5. What is normal reaction? 600. Normal reaction as in the perpendicular one. No? This is the normal reaction right now, right? 600 one. That is the normal reaction. Normal reaction means perpendicular to the surface. So here, this is the surface. You are pressing a force like this. So this is the normal reaction you are going to get. And hence I took this problem, just a small but very interesting problem. Okay. And now the person is going to accelerate in the downward direction. Okay. The weight of this guy is 60 kg. So that's it. Mass into acceleration, okay, which is 60 into acceleration, which is the force in the direction of acceleration mg. So that's 60 into g, which is the force in the opposite direction. That's friction, that's 0.5 into 600. Okay. So we have got 60A. This is 600. I'm taking GS10. They have mentioned GS10 anyway. So 60 into 10, that's 600. 0.5 into 600, that's 300. 600 minus 300, that's 300. So 60A, that will be 300. So A is how much, people? 300 upon 60, which is 5. Just a very interesting small problem. Make a note. A realistic problem. Acha, do you have any questions in 2D velocity, 3D velocity, or Newton's law or friction so far? In any theory, anything that you can recall, if you have been revising, anything around this?
सर सर्कुलर मोशन में थोड़ा पोलर में सर्कुलर मोशन में थोड़ा कंफ्यूजन है.
पोलर, अच्छा 2D पोलर यू?
यस सर.
ओके, क्या कंफ्यूजन है, बोलो.
सर ये मैग्नीट्यूड एंगुलर वेलोसिटी का मैग्नीट्यूड कांस्टेंट रहता है.
हाँ, यस.
बट डायरेक्शन चेंज होता है.
नहीं, एंगुलर वेलोसिटी का डायरेक्शन भी तो कांस्टेंट रहेगा ना, सर्कुलर मोशन है.
यूनिफॉर्म सर्कुलर मोशन.
हाँ, यूनिफॉर्म सर्कुलर मोशन में, बट नॉन यूनिफॉर्म सर्कुलर मोशन भी रहेगा, तो भी इवन देन आल्सो एंगुलर वेलोसिटी का डायरेक्शन विल रिमेन कांस्टेंट. द थिंग इज, एंगुलर वेलोसिटी का डायरेक्शन इज व्हाट? राइट हैंड कंट्रोल, ना? दैट्स इट. सो एज फार एज द प्लेन इज फिक्स्ड, एंगुलर वेलोसिटी का डायरेक्शन विल बी फिक्स्ड.
रेडियल वेलोसिटी डायरेक्शन चेंज होगा.
रेडियल वेलोसिटी का VR, that will change. Tangential velocity, that will change. But this
मैग्नीट्यूड पोजीशन में डिपेंड करेगा ना सर?
रेडियल वेलोसिटी का मैग्नीट्यूड,
पोजीशन,
which is r dot. हाँ, मतलब that's dr by dt. So yes, it will depend on position of absolutely. Yes.
Okay sir.
ठीक है? Clear?
Yes sir.
So because you asked this, so one of my favorite MCQ that I usually ask on UCM, MSQ rather. So I just ask students that in uniform circular motion, which of the following statements is or are correct? And then I give them 4 options. Like for an example, that linear speed is constant, linear velocity is constant, okay? Angular speed is constant, angular velocity is constant. And now I can add on to this. I can actually further also add on to this. So when you say uniform circular motion, obviously speed will remain constant. Speed will remain constant. But when it comes to velocity, velocity depends on direction. So obviously here the velocity is continuously changing because this velocity is tangential, no? So this direction is continuously changing. So since direction is changing, velocity is not constant. B is incorrect. But angular velocity, that will remain constant because here the direction, that will always be upwards, people. So this will remain constant. Angular velocity remains constant, but linear velocity, that does not remain constant. Similarly, you can talk about, for example, kinetic energy. Kinetic energy is half mv square. It's a scalar quantity, no? Mass is scalar. V, if people V is constant, then V square is also constant. Kinetic energy is also constant. Okay, kinetic energy is also constant. For example, if you talk about F, angular momentum wave, that's R cross P actually. So this is R cross mv actually. Now this is changing because R is continuously changing, V is continuously changing. So you can say R cross. No, wait. R cross V. Again, that will also, this will also be constant, no? Why? R cross V, it is always upwards. Don't you think? This is interesting now. I'm glad I took this question.
Yes, sir, omega.
Because R cross V, that will actually remain constant here. Why, people? If you take any point, let's say this point, this is R vector, this is V vector. What is R cross V here? It's upwards, no? Keep your fingers on the right side, curl it inwards, thumb is upwards. Now at any point, it will be upwards. It will be upwards. For example, here also, it's R cross V. Again, keep your fingers on the right side. Velocity is outwards, people. Velocity is outwards. Thumb is still upwards. Okay. So angular momentum is still constant. This is interesting. And since angular momentum, vector angular momentum is constant, what happens to torque?
Zero.
Okay. For example, what happens to power? Chalo, work done.
Zero.
First of all, work done you can say. Work done is zero because work is force into displacement. Force and displacement are perpendicular to each other here. Force is centripetal. Displacement is tangential. No? Displacement every time is tangential. Force is centripetal force. So angle between them is 90 degree. Fs cos 90. People, what is A dot B? AB cos theta. And force is centripetal. Displacement is tangential. So radius and tangent are perpendicular to each other. Because they are perpendicular to each other, Fs cos 90, this will be zero. Since work is zero, power is also zero. Power is rate of change over time. So good question on this again can be framed anything. In this, the most interesting part is actually this. Actually, this should be asked because that is the most interesting one. Because students may think it's not constant. That's actually constant. Nice. Okay, chalo, next. I hope you have copied this.
Sir, option A में B constant and B में भी B constant.
This is V vector ray. It's not constant. Wrong.
Okay, sir.
V vector. So it's velocity. V is speed. So speed will remain constant. But direction of the speed with velocity, that will not remain constant. So here omega will remain constant, but omega vector will also remain constant. Both of them will remain constant. Angular speed as well as angular velocity. Clear?
Yes, sir.
Okay. Let's take next question. Anything else, people? You can always ask. Sure. Let's proceed. Last was question number 9. Now let's take question 10. Okay. Okay. So a man climbs down a hemispherical hill of radius 100 meters from the topmost point. If the coefficient of friction between the shoes and the heel is 0.1, then approximately how much distance does he have to walk before he slips? People, when he will slip, what will happen?
Normal reaction becomes zero.
Normal reaction equals zero.
Yes. But no, wait. It's not that he's going to fall, but okay. Okay. So when will the slipping exactly start? When friction first of all reaches its maximum possible value now. Okay, wait. It's slipping, it's actually not exactly falling, but okay. Let's say the person is here, somewhere here. Leave it, sort of. Let's say the person is here. And at this point, he is going to slip. So when exactly will he slip? Normal reaction becomes zero, that's okay. I mean, that's basically when he will lose the contact. So here it does not mean that he will lose the contact, but he slips. It means static friction is converted into kinetic. Only then he can slip here. So static friction has reached its maximum potential. Fs has reached its maximum potential. Okay, so it means it becomes mu s into n actually. Okay, so mu s is 0.1 into n. Okay, so that's Fs. Now here he has weight mg in the downward direction. So you have to resolve this in two components. So this is one component, this is another component. Let's divide angle, people. So let's say this is angle theta. Okay, let's say this is theta. So this also becomes theta.
Sir,
हाँ बोलो.
sir, here also the guy will slip. So why then we are taking it as static friction? And why then we should take it as kinetic now because it has started slipping?
No. The point is, at what distance, until what distance he will walk before he slips. So just before he slips, it means friction reached its maximum value, no? And now he is going to slip.
Yes, sir.
Okay.
Yes, sir.
So this is theta, people. So this becomes mg cos theta. This becomes mg sin theta. This is normal reaction n. Okay. Okay. So normal reaction is balanced by mg cos theta because heat is like, is he oscillating up and down? No, no. So normal reaction is balanced by mg cos theta. Okay. Okay. And friction is going to act in the opposite direction. Fs. It has reached its maximum value. Okay. When you say just before he slips, okay. So when you say it slips, it means acceleration. He is going to accelerate post to that. Before that, he is simply walking, let's say, with some constant velocity. It's like a uniform circular motion kind of stuff. But after that, people, what happens when you slip? It's like suddenly you were accelerated. No? You're usually walking with some constant speed. And suddenly, if you slip, it means there was a jerk, people. There was a sudden jerk, there was an acceleration. Okay. So the point is, when you say just before he slips, it means acceleration was zero at this stage. After he slips, he is going to accelerate. As soon as he slips, he is going to accelerate. But what should be the tendency of direction of acceleration? This is the direction of acceleration. Okay. So mass into acceleration is provided by, who is the force in the direction of acceleration?
So can you understand that he has not started slipping it? It is all before he slips. But in
Just
the previous
before.
question, yes, sir. But in the previous question, we have a monkey, and monkey was at rest, but then he slides down. But here we had to talk about with what acceleration will the fireman slide down. And here again, we are taking it as US. तो यहाँ तो kinetic लेना पड़ेगा ना?
No. Again, I'm not understanding here. Acha, okay, here. The point is, we can always take kinetic, but that's what we had discussed also in the live class. That unless and until they don't mention exclusively that this is static friction, this is kinetic friction, you will assume that static and kinetic are approximately equal. Because anyway, at the end of the day, their values will be hardly, very far away from each other. It will be very small difference only between them. So, for example, I don't think they have mentioned static friction as clearly. They have just mentioned coefficient of friction. Understood? Have they mentioned static?
Yes, sir.
Have
Then
they
we can
mentioned kinetic?
simply write mu.
So you have to take
No,
it
sir.
to be mu. Just take it. Okay.
Yes, sir.
Okay. Next. No problem, but so MA, mass into acceleration, this is given by mg sin theta, the force in the opposite direction. That's maximum friction that the person has reached, because after this he is going to slip. After this he is going to slip. Okay. But just before slipping, obviously the person, let's say, is walking with constant velocity and there was no acceleration. So once he slips, there will be acceleration. So let's say acceleration is 0 here, mg sin theta minus fs max. Throw fs max on that side. Okay. So what do we have? We have already got n is mg cos theta. On the other hand, we have got fs max is mg sin theta. But what is fs max? Fs max is mu s into n. Fs max is mu s into n. This is mg sin theta. See, again, I am writing mu s, but at the end of the day, here also in the question, they have written coefficient of friction. They have not written kinetic or static. Anyway, so take ratio now. So what do we have? Divide equation 2 with 1. 2 divided by 1. Okay. So I've got mu s into n upon n. This is mg sin theta upon mg cos theta. Okay, so NN gets cancelled. We've got MS, which is popularly tan theta. This is also one of our favorite forms. Mu S is tan theta. But remember, not every time it will be tan theta. It could be cot also depending upon the theta you have chosen. I have got theta here. If theta would be something else, suppose if this was theta, then maybe you would have got cot theta. Okay, not maybe you will get cot theta if that would have been the theta. So depending upon theta, the formula will change. Take care of that. So mu S is tan theta. Okay, so we have been given mu S people, which is 0.1. So 0.1 is tan theta. Now what to do after this? What is the question, by the way? Question is, then how much distance does he have to walk before he slips? People, what is it that they are asking? Here is the person. Okay, this is, let's say, the hemisphere. The radius is given to you 100 meters. The person was initially here.
Length.
Arc length, you know, and here the person slips. So they are asking you find how much distance the person will walk before he slips. It means arc length they are asking, and hence again a very interesting question in itself. Okay, arc length, small h. So how can we find it? This is theta. Obviously, you know,
R theta कर देंगे.
exactly, S is r theta. That's it. So it's 100 into theta. The thing is, this is 0.1. It's very small. So I can say tan theta can be approximately written as theta. So theta is approximately 0.1 because it's very small, right? Theta is 0.1. So your answer is 100 into 0.1, which is 10 people. Option B. Interesting. Make a note, copy, ask me if you have any questions. Don't hesitate, please. Are you finding these questions helpful? Just asking. Or do you think we should go with theory? So,
no, sir, this is very helpful.
You know,
questions.
Right. So, I mean, going through questions only the way we will explore these concepts more. I mean, these are the chapters where only solving questions matter. Chapters like central force or places, those are the places where maybe noting down the formula and recalling theory could matter more. But okay. The thing is, it's actually a kind of a revision lecture. It's not exactly what do you call it, a crash course. If it would have been crash course, then we would have done more problems and covered small theory also. So I am still not sure how exactly should we go about the revision lectures. But okay, we are still going it with the flow. Any questions, people? Next. So friction is covered nicely. Okay, let's proceed. Let's take another question here. Okay, so there is another question I am taking on friction actually. Just for, I don't know, people, I have been coming across some good questions and I feel like I should teach you this, I should teach you that. I always feel that thing. But okay, so this is another very good question. So they have given us two bodies of identical mass are tied by an ideal string, which passes over an ideal pulley. Okay, ideal stuff, identical. Okay, so identical masses, it means this is M, then this is also M. Okay. Next, the coefficient of friction between the bodies and the plane is mu. Okay, so all the surfaces are rough actually. Okay, because coefficient of friction exists. Okay, the minimum value of theta for which the system starts moving. Listen, first of all, we have to identify the direction of its motion. Obviously, this is the only place. This is how only it can accelerate. Huh? There is no other place where it can accelerate. But they are asking you the minimum value of theta for which the system starts moving. So this is the tendency of acceleration, but you will eventually substitute acceleration as 0. So just when it is just about to start, what is the meaning of that? Again, friction has reached its maximum possible value. Okay? So friction Fs has again reached its maximum possible value, which is mu s into n, or just write mu into n. Again, they are just writing coefficient of friction. They are not writing static, but we understand it is static here, because they are asking the theta for which it just starts moving. Okay? So Fs is mu s into n. Okay. A common mistake which you might end up doing is assuming that the friction will remain same. People, friction cannot remain same. Now why? Even the coefficient of friction is same. Friction will not be same.
Accelerating, sir.
Normal reaction to
Yes.
अलग है ना?
Normal reaction is different now. Both of them are. Okay? Here you have got mg. Here the normal reaction is different, which is n1. So here n1 is mg. So here the friction will be different, even the coefficient of friction is same. Similarly, here you have got mg, but normal reaction is not mg this time. Mg has two components, people. Now mg has two components. Since this is theta, this will be our theta like we know. This becomes mg cos and this becomes mg sin. And normal reaction this time is mg cos. This is a mistake which I did in my first attempt of solving during my times. I did this in 2017 in one of the practice papers. Okay. So N2 is actually mg cos theta. It's not mg. It's mg cos theta. Okay. And mg sin theta is the one which is going to make them accelerate. So that's good. So obviously frictions will be different. We know the direction of frictions. Frictions will try to oppose. So here you have friction F2. Here you have friction F1, people. Frictions are different, but it will reach its maximum value. That's for sure. Okay, because system just starts moving. So friction 1, that's mu into N1. So that's mu into mg. And friction 2, that's mu into N2. So that's mu into mg cos theta. Okay, and remember there is tension also along the string. But don't forget, there is tension T. There is tension T along the string towards the point of suspension. Any questions until here, anyone? All good then. So let's apply acceleration formula. So what do we have? Mass into acceleration is given by, which is the force in the direction of acceleration, mg sin theta, which is the force in the opposite direction, F2 and T. F2 and T. Let's apply formula here too. Mass into acceleration, which is the force in the direction of acceleration, tension T, people. Tension T, and which is the force in the opposite direction, F1. I hope you are with me. Let's add them. MA plus MA, 2MA. T minus T gets cancelled. We have got mg sin theta minus F2 minus F1. Acceleration is 0. Okay. So this is mg sin theta minus F2 minus F1. Throw minus F2 minus F1 on that side. So that becomes plus F2 plus F1. Okay. So we have got F1 plus F2. This is mg sin theta. Acceleration is 0, people. Acceleration is 0. I've just thrown F1, F2 on that side. F1 plus F2 is mg sin theta. Any questions, anyone until here? All good. Should I go to the next page?
Yes, sir.
Let me know if anybody's writing, drawing, taking. Most probably you guys are taking screenshots, so that's good. Anyway, so F1 is mu into mu mg. F1 is mu mg plus F2 is mu mg cos theta. Okay, and this is equals to mg sin theta. Okay, first of all the mg gets cancelled. We have got mu plus mu cos theta. Okay, this is g sin theta. Sorry, just sin theta. Let's take mu common. 1 plus cos theta. This is sin theta. We have got mu, which is sin theta upon 1 plus cos theta. Now the thing is, people, honestly, only because I have been teaching since many years and I have taught mathematics too, I have taught physics too, like mathematics to 11-12 kids, physics to also to 11-12 kids. And I have been in constant touch with all the formulae of derivatives and integration and trigonometry and everything. After this step, I knew what I'm supposed to do. First, I want to ask you, any idea, do you know what you are supposed to do here? First, have a look at the options. Have a look at the options. Everything is in terms of cos. First of all, cos inverse of something. So you have got something inside. Okay, so you have to get rid of sine maybe, and you have to find things in terms of mu. But what will you do after this? That's the biggest challenge. We have to get rid of theta. You have to find theta. Bolo?
Half angle formula.
Perfect. Chalo, that's the first good attempt. Half angle formula. Very good. So people, sine theta can be written as 2 sine theta by 2 cos theta by 2. Okay, and 1 plus cos, 2 cos square. So that's 2 cos square theta by 2. 2 gets cancelled. Cos and square gets cancelled. So mu, you are going to get sine theta by 2 upon cos theta by 2. So you are getting mu as tan theta by 2. But now what? The step was correct, by the way. But now what? All the options are in terms of cos. And you want to find theta.
थीटा tan inverse करके
cos 2 theta की sin होती है 1 minus tan square x.
Perfect. That's it. That's it. So that is what you needed here. So because you have got tan and you want to find the cos, there is a relationship between cos and tan which you are supposed to recall here, and that is cos theta can be written as 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. I hope you recall this from your 11th, 12th standard high school. I'm not sure if we have used this throughout our classical
Yes,
mechanics
sir.
or
I-
throughout quantum. We have not used this lately. But this is the reason I wanted to take this question in the class, so that I remind you that you are supposed to go through all the trigonometric formula today itself after the class. Pen down all the trigonometric formula, pen down all the vector algebra formula too, like A dot B cross C, A cross B cross C, those fundamental steps. Pen down arithmetic progression, geometric progression, all the progressions. Basically, all the fundamental mathematics people cover it tonight only. Some limits formula also, like limit of 1 plus x upon x, limit of sin x upon x. Any fundamental stuff that you are able to recall from 11th, 12th books, just go through it. Okay. So, but that's it. So this is 1 minus mu square upon 1 plus mu square. Theta is actually cos inverse of 1 minus mu square. ठीक है चलो writing anything please copy take your time. Because what would have happened in exam, this would be a very tempting question to solve. Most of you would have solved it and you would have probably reached until here, and after this you would have ended up wasting 2, 3, 4 minutes unnecessarily if you just that formula, if you would not be able to recall it. There are different ways to get the answer, but that would be a very elongated. You can always find a theta maybe, or maybe draw a right angle triangle. Actually, what is my favorite method? I usually plot right angle triangle to do things. So for an example, if I would know that tan theta is, let's say, 2t upon some x square, something like that, and I want all the options in terms of sine, or everything is in terms of cos. People draw the triangle. What is tan? Opposite upon adjacent. That's it. Draw the triangle. This is theta. What will be opposite? 2t. What will be adjacent? X square. So what will be this? Under root of 4t square plus x square. And if all the options are in terms of sine, find sine. If all the options are in cos, find cos. This is my favorite method.
X power 4.
ठीक है? So x raised to 4. Okay. ठीक है. So this
So
is
can
also
you please
something-
repeat?
So the point is, if suppose tan is given to you, but suppose you ended up finding this in a solution, you solved 6-5 lines and you got this, but you are seeing that all the options are in terms of sine. So what to do immediately after this? Tan theta, opposite side upon adjacent side, right? So you just draw a triangle. You will call a theta. So opposite of theta, so who is opposite? 2t, no? Who is adjacent? X square. So what will be hypotenuse? Under root of 2t square plus x raised to 4. Now I can calculate sine theta. No? So what is sine theta? Opposite upon hypotenuse. 2t upon under root of 4t square plus x raised to 4. Understood?
Yes, sir.
Okay. Chalo. Next. Proceeding ahead. Next question, number 12. So now these are the questions on variable mass system, people. We already know the concept of variable mass system. Thrust force, that thing exists, V dm by dt. But I wanted to take some good questions in the class related to that again. So this is a very good one, but I can teach you a few more things. Okay. So spaceship of mass capital M enters a stationary dust cloud of mass density rho with a speed v0 at time t equals to 0. Okay, so there is a spaceship and they have given us that initially it has a mass m and initially it has a speed v0, and now it is going to enter a cloud of dust p. Okay. And they have mentioned, if the dust particles are assumed to stick to the face of the spaceship of area capital A, then its speed at a later time t is. So they are asking you the velocity after some time t. First of all, when the mass will stick to the spaceship, what will happen to its velocity? Increase or decrease?
Decrease hoga.
Decrease.
It has to decrease. So there will be deceleration that is going to happen. There will be thrust which is going to act in the opposite direction. But okay, that's one thing. Secondly, okay, so here also you can apply, let's say after some time t, once let's say some dust particles has It is stuck to the spaceship. Let's say some dust particles is now stuck to the spaceship. Let's say the new mass is small m people. We don't know the value of small m. And let's say the new velocity is v. We don't know the value of velocity v also. I can apply law of conservation of linear momentum on this. So initial velocity m into v naught. This will be equal to initial momentum into v naught. That will be final momentum small m into v. There is no external force acting on the system. Okay? So m into v naught, that will be small m into v. So what do I have? I have got m into v naught upon v. This is small m, or m into this is small m. That's fine. Okay. V is final velocity. Yeah? This is the final case. We don't know the value of v. Okay, and this is initial.
M is instant mass, sir.
M is mass at this velocity. M is that instantaneous mass. V is that instantaneous velocity. They both are function of time right now. They both are function of time. So at this velocity, this is the mass. That's the idea right now. Okay. Now I can apply Newton's law also. So people, one thing is clear: thrust force has to act in the opposite direction. Okay. But you write system is moving in the forward direction. System is moving in the forward direction. So there is acceleration. But remember, technically it will become deceleration. It is because velocity is going to decrease now. Because it is going to decrease, it is actually going to become deceleration now. So at any time t, please tell me if you want me to explain any concept in this again. These are the kind of problems which you have to expect in exam. There will be one problem on variable mass, people, raindrop problem or spaceship problem, or the trolley problem or whatever. They like asking questions related to variable mass, where differential equations can also be used, mathematics can be used. Okay. So at any time t, okay, let's say the mass is m and the velocity is v. That's what we wrote. Mass is m and velocity is v at any time t. At any time t. Okay. So mass into acceleration is given by. Is there any force in the forward direction, people? Any force? There is no force in the forward direction, zero. But there is a force in the backward direction, that is thrust force. Are you with me? Any questions? Any confusion?
Yes, sir. No, sir.
Okay. So MA is minus FT. Minus means what? It tells you now that acceleration is decreasing, it's retardation, which is correct. Mass is going to add, acceleration will decrease, it is going to retard. Okay. So mass into acceleration, what is thrust force? V dm by dt. Okay. So MA, this is minus V. Now we know what is dm by dt. We have done this ample amount of times. So let's do this. Dm by dt, this is equals to d by dt of what is mass density into volume. So this is d by dt of rho into what is volume area into length. So rho outside, area is constant of the spaceship. We are assuming it's a cylindrical spaceship because they have mentioned that it has area A. Assume it's a cylindrical spaceship or whatever. Okay. So let's say rho into A, this is dl by dt. dl by dt, that becomes v, people. Rate of change of length with respect to time. That's v. So dm by dt is rho av. We have also done this thing again quite a few times during classes. So I mean, what is acceleration? Rate of change of velocity with respect to time. This is minus rho a v square. That's it. And now we are supposed to integrate. Copy this much.
The previous slide.
Sure. And how? Small m is not constant. We have to substitute small m too. Small m is not constant. It is capital M v naught upon small v. See, I would have assumed small m to be constant right now. Small m is not constant. Okay. It depends on v. It's capital M v naught upon v. So let's substitute first that capital M v naught upon v. That's small m actually. Okay. dv by dt. This is minus rho a v square. This is what we are supposed to integrate and solve. Because in this capital M is the initial mass, that is constant. V naught, that's initial velocity, that is constant. Area is constant, density is constant. We have got velocity time relationship. And that's what we are asking you now. Find the velocity time relationship. Tell me if there is any conceptual question. You can ask me to re-explain repeatedly now.
Sir, एम इक्वल टू 0 माइनस एफ टी कैसे? एफ टी होना चाहिए ना?
नहीं, because MA is in the forward direction. Thrust is going to act in the backward direction, no? Because particles are sticking on the spaceship, no? So it is going to push the spaceship in the backward direction, no?
Yes, sir. Okay.
And minus only tells you that it is retarding. Okay. Then should I go to the next page? Writing. Next. So what do we have? M into V naught. Let's throw all the constants on one side and just velocity on one side. I will do it that way. So what we will do is, first let me write this equation. M V naught upon V dV by dt is given by minus rho a V square. Now, just let's bring velocity with velocity. Okay. So dV upon V you already have. If you throw V square here, it becomes V cube. And here you have minus rho a upon M V naught. Okay. M V naught dt. Have I written things correctly? Just check. dV upon V into V square, that's V cube, and minus rho a upon M V naught into dt. Let's integrate now. So limits we have to take care of. Initially when time was 0, what is velocity? Don't
V
write
naught.
0, huh?
V naught.
It's V naught. Take care of that. Velocity was initially V naught, people. Don't write 0. Okay. And they are asking you what is the velocity expression at any time t. Okay. So after this, I think you can do. I will just tell you the answer. Or wait, is there? Okay, no, I think we'll solve it. Maybe there is some manipulation that needs to be done now. Okay, so let's complete this. No problem. So what is integration of 1 upon V cube? That's V raised to minus 3, which is V raised to minus 3 plus 1 upon minus 3 plus 1, which is V raised to minus 2 upon minus 2. That's minus 1 upon 2V square. Okay, minus 1 upon 2V square. That's the value. Minus 1 upon 2V square. That's the integration value. V naught to V minus rho a upon mv naught. Okay, integration of dt, that's t 0 to t. First of all, let's cancel minus minus. Okay, so and you can throw 2 on that side. Upper limit minus lower limit, so that's 1 upon v square minus 1 upon v naught square. This is 2 rho a upon m v naught. T minus 0, that's t. Okay, so I think we are very close to the answer. So 1 upon v square, this is given by 2 rho a t upon m v naught plus v naught square. Correct, right? So we have got, okay, I need m v naught. Okay, so we will do LCM here, right? Let's make this v naught square. Let's multiply and divide by v naught. So 2 rho a t v naught upon m v naught square. I've just multiplied and divided by v naught. And here let's multiply divide by m. So m upon m v naught square. Denominator becomes same. Now denominator is same. So I can add the numerator directly. So 1 upon v square, this is 2 rho a t v naught plus m upon m v naught square. Copy this much.
Yes, sir.
Okay. So we have got 1 upon v square. This is given by 2 rho a t v naught, 2 rho a t v naught, 2 a t v naught plus m upon m v naught square, plus m upon m v naught square. So v square we have got, which is m v naught square upon 2 rho a t v naught plus m. Let's analyze the option first of all. Okay, so option has v naught as a separate term and there is no mass in the numerator. So we have to get rid of mass and we need only v naught. So let's take mass common from denominator first of all. This is how you analyze, right? Once you reach a step, people, you first have to check the options. So in options, there is only v naught and there is no mass. So you have to get rid of mass. Okay. So 2 rho a t v naught upon m plus 1. Mass gets cancelled. We have got v square, take square on that side. So v naught square becomes what, people? V naught. And this whole term becomes root. So we have got 1 plus 2 rho a t v naught upon m, the whole raised to half. So root means half, no? So our answer, I think we got the answer. This is the answer. V naught into 1 plus 2 rho a v naught t by m raised to minus 1 by 2. Not much of a manipulation actually. Nice. Copy please. This goes in the numerator and it becomes minus half. 1 plus 2 rho at v naught upon m raised to minus half. Clear, people? And these revision lectures should be an eye opener to you, that if you are wasting your time in reading theory, it's not going to be helpful. You have to just practice numericals and numericals and numericals and numericals. Whatever books you have, whichever books you have, soft copies, hard copies, solve, practice, solve, practice. Only that is how your rank can be improved now, people. Okay? Don't waste your time in reading theory, people. Just solve and solve and solve. So I've just tried to take good questions, conceptual questions at places, and at places we are revising things. Chalo, done? Let me know if anybody is writing, okay? Next. There's another question on variable mass I would like to take, but this is a different kind of a question. Okay, not something which you see usually in a variable mass problem, but it's a thrust force problem, very, very good one. Small problem, but okay. A uniform chain of mass m and length L hangs from a thread and touches the surface of a table by its lower end. So see, there is a table and there is chain. Okay. And it has length L people. And it's uniform and it has mass m. Okay, it's uniform also. So mass is equally distributed. Find the force exerted by the chain on the surface when 3/4 of its length has fallen on the table. Okay. So now you just have to release it. You just have to release it, and what will happen? It is going to fall, fatapat. But people, while it will fall, what will happen? It will exert a force on the table because the chain is falling now. So while it will fall, it will exert a force on the table. What is that force actually? Thrust force. Because mass is continuously changing. Initially the force exerted was by the total mass. As it falls, people, as it falls, what happens? The mass is continuously changing here while falling. Velocity is continuously increasing while falling. A lot of things is happening during the fall. Okay, so thrust force is continuously being acted on the table. So after some time, when 3/4 of its length has fallen on the table. Okay, so 3/4 length is already on the table. Okay, and only 1/4 is in the air. Let me just try to ensure that it looks like it. Okay, and only 1/4 is on the air. Something like this maybe. Okay. Okay, so this is 3/4 people, which has fallen on the table already. 3/4 times length, and 1/4 is on the table. Okay. My question right now is, even though we know we have to use thrust force or whatever, at this instant where they are asking, what is it that they are asking? Find the force exerted by the chain on the surface. Okay, first of all, so there is two forces. There are two forces which are going to be exerted by the chain on the table. One will be due to this chain which is already on the table. And what is the force due to this chain which is on the table? It will be weight.
Normal reaction.
Normal reaction or weight of this chain. Weight of this chain. What will be the mass of this chain, people?
1/4. So 3/4 of this.
3/4 of m, no? It's 3/4 L, so it will be 3/4 m. Total mass is m, people. It's uniform, no? It's uniform. So if the length is 3/4, mass is also 3/4. Okay. So first of all, 3/4 m into g. This is due to the one which is already on the table. The one due to already on the table. Tell me if you have any questions. This is the weight of chain. Okay. Weight of chain already on table, which is mass into gravity, but mass will be 3/4 times. Because length is 3/4. Simple, and it's uniform. And now, due to this, there will be a thrust force, people. Due to this, there will be a thrust force. It is falling. It is not exerting a weight, people. It is suspended by a length. Now remember, this is not exerting a weight right now. They have mentioned it that it was hung from a thread. So there is no weight exerted on the table. But because it is falling, due to the fall, there is a thrust force. And that thrust force is given by V dm by dt. So we have got 3 by 4 mg plus v dm by dt. So now we want to find what is the velocity at this instant. How can I find velocity at this instant, at this particular instant?
मोमेंटम कंजर्व करके
Okay,
Kinematics.
kinematics, like kinematical equation, v square is u square plus 2as. Perfect. Okay, so v square, initial velocity was 0. It is falling with gravity, absolutely. What is the length that it covered?
L by 4.
Nahi.
3 by 4.
3L by 4, na? It covered a length of 3L by 4. Now only L by 4 is remaining, right? Initially the length was L, and 3L by 4 has fallen. It means the length covered was, distance covered is how much? 3L by 4.
Yes, sir. 3L.
Okay. It's okay. It's a very common mistake that happens. Okay. So V square is 3GL. Okay, wait. It is 3GL by 2. And what is dm by dt? We already know dm by dt. Rho AV. How many times should? Actually, no, not AV this time. We'll have to do this. It's length. We have to use
It's
linear
linear
density.
mass. Linear mass.
Linear density, right? So V is dm by dt. So this is d by dt of what is mass, people? Lambda into length. Because lambda is mass upon length, no? Lambda is mass upon length. So mass is lambda into length, correct? So this is lambda into dl by dt, which is lambda into v actually. And lambda is mass upon length. Are you with me? Any questions, anyone?
So
Lambda
take
is
previous slide once.
just a second. So velocity is people dm by dt, which is d by dt of lambda L. Okay. Lambda I've thrown outside. dl by dt and dl by dt is v. Now lambda is uniform. It's density. So it is total mass upon total length. That also you can write, or small mass upon small length. That also you can write. Doesn't matter. So I'm now writing total mass upon total length. It is small m upon L into v. I hope it's fine. Okay. Sorry, just a second. This is just a dm by dt. Just a dm by dt. Okay. Now copy this first. Okay.
मोमेंटम कंजर्व नहीं होगा सर मोमेंटम से
मैं सोच रहा हूँ वो कैसे आप अप्लाई करोगे. आपने बोला तो सही, बट आई एम थिंकिंग हाउ विल यू अप्लाई. लाइक
लेंथ चेंज हो रहा है अकॉर्डिंगली मास भी चेंज होगा एमबी बोलने से नहीं होगा.
so but m is also changing na here. So momentum conservation, how will that help? So I'm asking. I'm also thinking just like last problem maybe. Just like last problem we can try. कर सकते हैं, मतलब that's also an attempt. You can try. See, let's get
velocity भी accordingly change होगा ना, set होगा.
Absolutely. So ठीक है. Something in the chat box. A. अच्छा, I don't know. Let's check whether it's A or not. Okay, done, people. Writing, drawing, copy.
Yes, sir.
Okay, so dIT is m by v into L. So what do we have? F net. F net is given by 3 by 4 mg. Okay, plus v into dm by dt. So v into what is dm by dt? M by L into v. Okay, so we have got 3 by 4 mg. Okay, plus m by L into v square. So we have got 3 by 4 mg plus m by L. What is v square? We have found out v square, people. V square is 3gl by 2. V square is 3gl by 2. So our answer is LL gets cancelled. Okay, and we have got 3 mg by 4 plus 3 mg by 2. So this is 3 mg by 4 plus 6 mg by 4, which is 9 mg by 4. Okay, and answer would be 9 by 4 is 2.25. 2.25 mg. Answer is option C. Ask me if you have any questions. Don't hesitate.
Yes, sir.
Okay, just a second. Chalo, next. Proceeding ahead. Now question 14. Okay, this one is actually, I think you can try later, or let me think, because we have already taken enough problem on variable mass. Do we need to do this or not? I'm thinking now. Why do I feel this is one of the JAM questions or this question, or it should be available in your Eduncle book too? But I will want you to solve this question, or go through this. Let me just see if it's available in. It should be available probably. Can somebody tell? Have you seen this in the theory of or in any of the paper?
सर वेलोसिटी इंक्रीज होगा ना टाइम के साथ, ऐसा कुछ था रेन ड्रॉप मॉइस्चर गैदर करके 2014 में.
हाँ मतलब I feel like raindrop ये जो है ना, it has to be one of the jam questions. I feel like we can take it right now. Actually, I'm just worried that see, I had only asked for 3 revision lectures. I will ask them for 4 also. That's not a problem. But again, if we keep solving so many questions from one chapter now, I'm not sure what will happen. क्या करें, ले या ना ले, चल कर लेते, leave it. We'll extend the class if required whenever. Okay, so let's do this. So raindrop falling vertically under gravity gathers the moisture of atmosphere at a rate this. Okay, and they are asking us at the end velocity of the drop after 1 second. First, let's solve this. We have got dm by dt is kt square. Let's find the mass, people, because we have to substitute dm by dt anyway here eventually. So we can do is dm is kt square dt.
Can't we just substitute it there? Just a suggestion. मतलब kt square को वहीं पर डाल दो उस equation में. Will that affect?
बाउंड्री कंडीशन डाल के
नहीं,
तो
the thing is, okay, wait, plus v into kt square. Okay, this is mg. So what after this? We can no, but the thing is, m is
Yes, sir.
changing continuously.
Yes, sir.
And we have got 3
Okay.
variables here. We have got m,
Okay,
v,
sir.
and t. We have got 3 variables. Mass is continuously changing, people. Velocity is continuously changing, and time is also changing. So now, first we have to find mass-time relationship, and then we can substitute mass here. Okay. Okay. So dm by dt is kt square. Then we have got dm is kt square dt. K is given to us 12. Everything is in CGS, take care. So dm is 12 t square dt. Let's integrate. When time is 0, take care, mass is not 0, mass is 2 grams, okay? And let's say at any time t, mass is m, okay? So m minus 2, this is 12 t cube by 3. That's it. So m minus 2, this is 4t cube. So m is 4t cube plus 2. We have got a relationship. Outstanding. Copy this much fatafat and take a snap for the question. Remember, never assume that mass is constant. Okay? Here also, if you would have substituted it here, in haste, you would have ended up taking mass as constant and maybe substituted 2 grams at the very end. Just take care. And I'm sure that option will be available. Okay. So, okay. Yesterday's that thing was very hilarious, where we got 6 and answer was there. Then we realized, okay, it's not 6. Okay. Chalo, next. Mass is done. Now substitute things here. Okay. I hope you have copied this much. So m into dv by dt, m is 40 cube plus 2. M is 40 cube plus 2. Okay. dv by dt. So now we have got only velocity time. Now, initially, what is the problem, people? Here you have got 3 variables: velocity, mass, and time. So I had to find a mass-time relationship so that we get 2 variables. Understood? So I found a mass-time relationship. Now I will get only 2 variable relationship. Okay? dv by dt plus v into dm by dt. So plus v into what is dm by dt? kt square. K is 12. So 12t square. K is 12. So 12t square. This is mg. M is 40 cube plus 2. I hope you have understood this. I've just substituted m, dv by dt as it is, v, dm by dt is 12t square and mg. Okay? And now this becomes which kind of a differential equation?
Linear.
Linear.
You just have to arrange it. Okay, throw 40 cube by 2 on that side. So dv by dt plus v into, or you can write 12t square upon 40 cube plus 2 into v. This is g, because 40 cube gets cancelled here. Okay, this is linear, people. This is of the form dv by dt plus p of t into v. This is q of t. How do you solve this?
Integration factor मान होगी
Integrating factor. Do you find integrating factor e raised to
pdx
pdx.
हाँ, मतलब
PT
pt here pt dt. ठीक है. So this is e raised to integration of, we have got 12t upon 4t cube plus 2 dt. What do you think is the answer of this?
12t square होगा
40 cube
हाँ, 12.
ln kt
Exactly. You have got
log tq log में आएगा ना.
yes. So you have got derivative in the numerator and you have got function in the denominator, people. Because what is the derivative of this function? Derivative of 4t cube, it's 4 into 3t square, no? That's 12t square. Outstanding. And derivative of 2 is 0. So we have got derivative in the numerator, function in the denominator. Answer is log mod function, people. Okay. Tell me if you want me to explain this, huh? Answer is log mod function. Whenever you have derivative in the numerator and function in the denominator, answer is just log mod function. Okay. And obviously plus c2. Sorry, in integrating factor, you don't. That's right. So this is e raised to, we have got 40 cube plus 2. But now what does this become? E raised to
40.
log of a, e raised to log of a to the base e. This is a itself. This is just a. Okay. So this is just 40 cube plus 2. Integrating factor is just 40 cube plus 2. Copy please. Ask me if you have any questions.
सर मेरा एक डाउट है सर.
बोलो ना.
सर इंटीग्रेटिंग कांस्टेंट कब डालेंगे सर?
नहीं, integrating factor में we don't put constant. Integrating factor is defined like we don't write plenty factor, we don't write limits.
नो सर, इंटीग्रेटिंग फैक्टर में सर जब हम इक्वेशन सॉल्व करेंगे तो c1 c2 लिखेगा ना, जब फाइनल इक्वेशन में आ जाएगा ये.
हाँ, वो तो फाइनल इक्वेशन में we will write, but only तब when you don't have a definite limit. हाँ, अभी definite limits है ना मेरे पास, so you don't write plus.
गिवन होगा तो नहीं डालेंगे कांस्टेंट.
हाँ, तो नहीं डालेंगे. Yes.
डालना पड़ेगा.
हाँ, वरना डालना पड़ेगा. Otherwise, like this, in this question also, for an example, you can also do it this way. Have a look, फटाफट. 12 integration of dm. This is 12 integration of t square. Suppose you are not putting the boundary condition, then also you can find constant. कैसे? This is m is 12 into t cube by 3 plus c. You want to write now, right? Plus c doesn't matter. Okay. So this is 40 cube plus c. But now constant, have they given you the constant? No, no. So it's your responsibility to find the constant. How do you find the constant? Again by substituting boundary conditions, and you will get the same thing. Because see, when time is 0, mass is 2. Substitute. Mass is 2 when time is 0. See, you got the constant which is 2. घूम फिर के you got the same equation. ना यार, doesn't matter. ठीक है?
Yes sir.
चलो, let's solve this. So what's our solution, people? We write v into integrating factor. This is integration of q of t into integrating factor, है ना? dt. You usually write y into integrating factor. Answer is integration of q of x into integrating factor dx. Correct? Have you you do this like this method only, no? You're mathematical, I'm not sure.
yes sir
Yes sir.
Okay, so this is v into what is integrating factor? 40 cube plus 2. 40 cube plus 2. This is integration of q of t. Q of t is just a g, gravity, into integrating factor, which is 40 cube plus 2. Let's say plus some constant c, you can just put dt. Okay, so our answer is, I'm not substituting any limits here at the moment. So 4 into 40 cube plus 2, this is equal. So should we substitute the limits maybe? Okay, so let's substitute the limits. What is it that they are asking by the way? They are asking us,
after 1 second.
find the velocity after 1 second. And initially it starts falling. Na? So initial velocity is 0, people. Starts falling. Okay. Initial velocity is 0. So time is 0. Acha nahi, but there is no limit on the left side. We have to use the constant method here. Listen. Now this is very important. There is no limits available on the left side, because in this solution you have not learned it that way. You have directly by hearted the solution. So this is where you have to use the constant method. Let's use the constant method. Okay. 40 cube plus 2. This is g into, okay, 4 outside. Integration of t cube, that's t raised to 4 by 4 plus 2 outside. Integration of t, that's t, and plus c. Now you have to write plus c here. Why am I using plus c method? Because I don't have options to substitute limits on left side. There is no integration. You have directly learned it this way without integration. Okay. So we'll use plus c method here. 4 4 gets cancelled. Now we have got V into 4t cube plus 2. This is equal to G into t raised to 4 plus 2t. G into t raised to 4 plus 2t plus constant c. Now our responsibility is to find constant c. They have given us when t is 0, velocity is 0 because it started its motion. So 0 into 0 plus 2, this is g into 0 plus 0 plus c. So 0 is 0 plus c, constant is 0. Constant is 0. So our answer is v into 4t cube plus 2. This is g into t raised to 4 plus 2t. And now they are asking us to find velocity at t equals to 1 second. Substitute t equals to 1. So v is 4 plus 2. Sorry, v into 4 plus 2. This is g into 1 plus 2. So v into 6. This is g into 3. So v is 0.5 times gravity. Everything was in CGS if you remember. Gravity is not 10 people. Gravity is 1000. 1000 grams per centimeter square. Just a second. It's not 9.8 meter per second square. It's 980 meter per second square. 980 centimeter per second square. 1000 basically. Okay. So this is 500 centimeter per second. I think I used gram. It's not gram. It's centimeter or kilogram. Whatever. Okay. Acceleration is 9.8 meter per second square. You write it 980 centimeter per second square, or you write 10 or 1000. So I've written 1000 because everything was in CGS. So answer is 500 centimeter per second. Option B. Nicely done. So with this, we complete the whole classical wala basic part. I mean, this variable mass is also done. And I don't think I have questions anymore left related to this. Good. So now we have to start with central force, people.
Yes, sir.
हाँ बोलो क्या बोल रहे हो
2017 में जो लास्ट वाला क्वेश्चन है कर दीजिए छोटा ये
अरे बाप रे ओके ठीक है you have to tell me what is the question or should I search it
सर्च इट सर
चलो okay wait let me first open the paper 2017 का कोई मुझे बोलता है ना immediately I am like okay
It's continue to hunt you down.
I have been hunted for so many years but just
10% is easy sir बहुत
चलो देखते हैं just a minute JAM PH 2017 because after giving the paper for 1.5 months I did not expect anything and then suddenly I am seeing okay AIR 45 because in 2016 in the marks that I was about to score like 45 or something I would have got rank beyond 300 or 200 but then all of a sudden you see such a good rank so okay 20 so that 1.5 months ka feeling was 2017 question paper okay chalo I will just share the screen where is the Zoom guy okay ha okay which question last
लास्ट
sorry okay so this is related to okay drag force वगैरह ऐसा ही कुछ है क्या okay let's try this okay so what do we have at t equals to 0 particle of mass m having velocity v naught starts moving through a liquid kept in a horizontal tube and experiences a drag force this it's a but how it is being moved liquid is horizontal but how it is being dragged vertically or horizontally okay I think it's minus dx by dt so it's actually I'm not sure if are you able to see the question I will just zoom the screen now. Wait. Where did the question go yeah no oh. Okay so let me just create white space again okay so we have got at t equals to 0 a particle of mass m having velocity v naught starts moving through a liquid kept in a horizontal tube we have a horizontal tube and we have a mass m particle having a velocity v naught and it experiences a drag force fd which is minus k dx by dt okay ठीक है it covers a distance l before coming to rest okay if the time taken to cover the distance L by 2 and L by 4 are T2 and T4 respectively, then the ratio of T2 upon T4 is, okay. So I will say,
टाइम एंड लेंथ का रिलेशन निकालना पड़ेगा ना.
because they have given us that we have to use v equals like instead of acceleration dv by dt, I think you will use v dx by dt or something like that. Let's check. So mass into acceleration, first of all, there is no forward motion. There will be only opposition. So there is deceleration that is happening. So this is fd. Okay. Remember, minus means already opposite. So if you are writing fd, I mean, since I am writing minus fd already, don't write minus of minus k dx by dt. This is a common mistake that you may end up doing. Because minus, I have already understood that minus is opposite. Don't write minus minus 2 times. So just write fd, okay, or write minus fd. It's up to you. I hope you're understanding what I'm trying to say here, people. Minus, I have already included that it's going in the opposite direction. I've used this minus sign to show the direction already. So don't write minus again. I've used the minus sign. Okay. So this is just k dx by dt. This is ma. So acceleration a, we can say it is this formula. One is dv by dt, that's fine. Other is v dv by dx. Okay, wait. Let's first think about dv by dt. So dt gets cancelled. We have got m dv. This is minus k dx. Okay. So m into integration of dv. This is minus k into integration of dx. Initially, velocity was v naught, and when it covers a length of L, it stops. Have you understood this first of all? Initially, velocity was v naught, and when it covers a length L, it comes to stop. M into 0 minus v naught. This is equals to minus k into L minus 0. So we have got minus m v naught. This is minus kl. So we have got a good relationship here. M v naught is kl basically. Let's see how exactly we will use this. We don't know how we will use it, but we have got a relationship here. And now we can use another fact that, just a minute. We can do one thing. This same formula I can again write m integration of dv. This is minus k integration of dx. Listen. At 0, velocity was v naught. Let us say at any random length L, let's say velocity is v. Okay? At any random length L, let us say velocity is v. So we will get, so I'm finding relationship between v and L here. Understood? Or you can write at any distance x. At any distance x, let us say velocity is v. Okay? Why am I doing this? Because I want time relationship. Now, how will I find time relationship? If you have acceleration, you differentiate, you get velocity. If you again integrate, sorry. If you have got acceleration, if you will integrate, you will get velocity. If you will again integrate, then only you will get position. And I want position and time relationship. So I want velocity time relationship first. Then what I will do is then I will integrate.
A को v dv by dx करने से नहीं होगा. A को v dv by dx करने से.
Arey, but it is not given in terms of x, no? It's given in terms of minus dx by dt.
Yes.
Problem is it is given in terms of time. Otherwise, I would have done that. Okay. So this is m into v minus v naught. Okay. This is minus of k into x. So we have got a relationship here. Okay. And that is, let me erase this. That is m, you can throw m on that side. So v minus v naught. This is minus kx upon m. So v is v naught minus kx upon m. Okay. And now you can find x and t relationship. And now you, after this, can you do this? Because velocity will be what? Dx by dt now. This is v naught minus kx upon m. Okay. And now all we have to do is integrate. Okay, I will complete this. First, please copy this. I will complete this because I cannot. This is, I'm doing this on the screen right now. It will not be saved actually in the PDF.
This is again a linear equation, right? You're getting another linear equation.
You don't need to do using linear equation. Variable separable is also fine.
Yes sir, direct हो जाएगा.
Direct हो जाएगा. Variable separable there it's fine. Otherwise, linear equation is fine, but it's not required in this book. Done? Copying. Take your time. I've been very tempted to see whether I was able to do this in JAM or not now in 2017. Because right now I'm able to do it. And I'm doing it for the first time. Huh? I've not done this question before ever. So
पेपर में क्या था नहीं किया था पेपर में
I don't remember. That's what I want to see. So I have the response sheet, you know that, right? So I will check it later. But after that, since like I'm teaching JAM since 2 years, so I have not taught this question in any of the live class. It's a good question. Shall done? Let's do this further. So now we can do this directly. So dx upon v naught minus kx by m. This is dt. So integration. Initially, position was 0. At any time t, position will be x. And then you have to take ratio. Time pass is ke baat, hai na? So, but okay, let's do this. What will we do after this? Multiply and divide by minus k by m. Hai na? Because I have got derivative in the numerator and function in the denominator. What is derivative of this? Derivative of v naught. V naught is constant. Derivative of v naught is 0. Derivative of this is minus k by m dx. Hai na? So this is minus of m by k log of mod of v naught minus kx by m. Any questions, anyone? Please ask me right now. This is T. Any questions, anyone? Please ask. Okay, so what do we have? Upper minus lower. So log of v naught minus kx by m minus log of v naught. This is minus kt by m. So we have got log a minus log b, that's log of a by b. So we have got log of v naught minus kx by m upon v naught. This is minus kt by m. I will require more space. Copy fatafat. Done. But you know, the best part is, even though we have learned only few topics in 2 revision lectures, but what we have covered is one of the best, are one of the best questions and the ones which could be asked in the exam. You know? I hope that this will be benefited. Let's see. Next. Let's complete this further. So what do we have? We have got v naught minus kx by m. Let's split this now. So we have got, why v naught? There should be v now somewhere. I've written something wrong somewhere. No, okay, it's in terms of x, nothing. Perfect. Sorry. So we have got 1 minus kx upon m v naught. Okay. This is e raised to minus kt by m. Are you with me? I've just taken e on that side, people. You know?
Yes, sir.
So, and I've splitted this part also. So v naught upon v naught is 1 and kx upon m v naught. Okay. So 1 minus e raised to minus kt by m. This is kx upon m v naught. So we have got a relationship m v naught upon k into 1 minus e raised to minus kt by m. This is x. So we want to find t. Okay, actually the thing is, okay, this is not required. We want t2 upon t4, no? We don't want x2 upon x4. So maybe this relationship only we could have used. Understood? We want t2 upon t4 actually, not the other stuff. Okay, wait. We have found a relationship, that's good, but we want t2 upon t4 actually. So let's do one thing. Let us just rearrange this. So we have got minus m by k into log of 1 minus kx upon m v naught. This is t, people. Okay, now you can find t2 upon t4. Okay, so what is it that they have given us? T2 is the distance as L by 2, T4 is the distance at L by 4, people. Okay, so minus m by k log of 1 minus k upon m v naught into x. Achha, what is k upon m v naught? Can you tell me, you have written it now? Or one relationship that we had found out. What was that relationship?
m v naught is equal to kl.
M v naught equals to kl.
Yes.
Okay, so let's first apply that. Good, nice. Now we are very close to the answer. So this is log of 1 minus kx. M v naught was kl now. Good. So kk gets cancelled. You have got minus m by k log of 1 minus x by l. Okay. Now listen, just a second before you proceed. Once you get a relationship, just verify whether your relationship is logically correct or not. People at x equals to 0, time should be 0, or at t equals to 0, x was 0, there was no motion. See if you are getting that or not. You are getting now, because when x will be 0, log 1 will be 0, time will be 0. It means it makes sense. It is making sense. You have not done any calculation error. Most probably you have not done a calculation error here, because x is 0, you are getting log 1 is 0, time will be 0. Okay, so let's find t2. T2 you have to substitute L by 2. So you have got minus m by k log of 1 minus half, that's log half. Okay, and T4, which is minus m by k log of 1 minus 1 by 4, that's 3 by 4. Log half and log 3 by 4. What is the answer be? Check. Log half upon log 3 by 4. Fatafat. Calculator, log half upon log 3 by 4.
at 2.4 or something.
2.42. Okay, let's check on answer key. Here we go. 2017 answer key, no? Please be correct. Yeah. Okay. So what do we have? Array, claps. Got it. Nice. Okay. 2.35 to 2.50 is the range. Any questions? Chalo, nice question. Good suggestion though. I mean, we did actually plenty of problems on variable mass, but one question is expected on this people. Okay. So I hope that this practice will be worth it. So we will stop here because we cannot start with central force now, and it's anyway just about to be time. All good, everyone? Okay.